good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, we're going to look at Theorem 8, and it states that if two tangents, if two tangents are drawn from the same point outside of a circle, then they are equal in length. I repeat, if two tangents are drawn from the same point outside of a circle, then they are equal in length. Meaning, if I have this common point here, A, and I have tangent passing through point C, as well as a tangent passing through point, point B, therefore, it means that these two tangents are equal in length. That is what the theorem is stating, basically. Now, let's try to see how did they come about this conclusion that these two uh, tangents are equal. Now, you are not required to prove this, but this is just me being genuine and showing you how they came about this. I still emphasize this again. You are not required to prove. The ones that you are required to prove, you'll see normally I say I give you the given I give you the given data. I do this given blah 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 blah, then RTP required to prove blah 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 blah. But if you do not see any this and see me proving, just know it is me just trying to make you understand how this theorem came about. Now let's construct our radius to point B as well as our radius to point C. Now, and also construct line OA like this. Yeah, we know that now what this line OB, it is a radius, OC, it is a radius. So it means OB it is equal to what? To OC. That one we can agree all. Why are we saying that? We are saying equal radii. All right. Now, then actually we are talking about OBA triangle as well as OCA triangle. So we are talking about two triangles here. Now, do you all agree with me that OA is a common point, a common side on these two triangles? Yes, agree. Then now, if you remember very well the theorem that we did on theorem 7, it says now a tangent to a circle is perpendicular to a radius at a point of contact. I repeat. A tangent to a circle, it is perpendicular. Let me do this. When I just talk, people do not see. A tangent to a circle is perpendicular to the radius of the circle, where at the point of contact. Where is the point of contact? The point of contact is this part, at point B. Alright? This point B, it is a point of contact. So this means now to us that this angle here, it is 90 degrees. Also this angle here, it is 90 degrees, because also AC, it is a tangent. OC, it is a what? It is a radius. Now we can prove that AB, it is equal to AC using what? Using congruence. Now how can we do that? Let's see. We're gonna say in triangle, let me write it here, in triangle OBA and triangle OCA. What? OA rather, it is a common. I like saying OA is equal to OA, which is unnecessary, but for me to see, you can just say OA is a common side, but I prefer saying OA is equal to OA to show that OA it is common and it is there on both this triangle. Again, OA is a common side. Then now OB it is equal to OC. Which OB am I talking about? This is the OB. OB it is equal to OC. Why am I saying that? We know equal radii or just radii. Oh, equal radii. Then now this angle here, OB, let me show you. Angle OBA, this angle here, it is 90 degrees. As well as angle OCA, this angle here, it is 90 degrees. Why? I'll say O angle BA, it is equal to O angle CA, it is equal to what? 90. Why am I saying that? Because now tangent, it is perpendicular to what? To radius. Then now this, if I'm done doing this, I've proven that. Remember when we were doing theorem 1, if we have a side as well as a 90-degree angle, you have proven congruency using this reason. Let me just say, therefore, triangle OBA is congruent to triangle man OCA. Why am I saying that? RHS. Therefore, I know if these two triangles are congruent, if these two triangles are like this, maybe, then this is a common side, then this angle is equal to that angle, then automatically this, it is equal. Therefore, AC, it is now equal to what? To AB. Therefore, AC, it is equal to what? AB. Why are we saying that? Congruent triangles. These two triangles are congruent. All right? I hope you are following. But you do not need to know how to prove that. What you need to know is that if you have a tangent from a common point A outside of a circle, and then and both of them are tangents to this one circle, this circle with center O, then it means those two tangents are equal in what? In length. Now, when you reason, if you have that part, you're gonna say tangents from a common point. This is your reasoning. If you were to say AB, it is AB, it is equal to AC. Why? This is your reason. Tangent from the common point. I hope you are following. And thank you very much, folks, for being with me again on Theorem 8. I hope we'll meet again under Euclidean Geometry, grade 11. That I still emphasize, it is assessed in grade 12. So if you liked the video and enjoyed it, please give it a thumbs up and kindly subscribe if you haven't. Until we meet again on Theorem 9. Thank you very much.